On Friday, we talked about this new kind of a function called a piecewise function, where the function experiences a drastic change. So it's going on, doing its thing, and then all of a sudden it changes and it just starts doing something completely different. So our piecewise functions look like this. They will be defined in function notation. So we'll be using f of x or g of x or h of x. And there will be two separate pieces collected together with one of those kind of squiggle brackets. First thing we want to do to graph one of these is look at where that sudden change happens. So the inequality tells us that at x is -3, the graph starts to behave differently. So what I'm going to do is at x is -3, put in a big vertical line that tells me at this point our graph decides to make a change. Then I graph each of the originals. So the first one, slope-intercept form, has an intercept of 1 and a slope of -2, down 2/1. I'm going to work my way back so that I get to where that separation line is, because I want to make sure that I graph at least a little bit on both sides of that line. Then I'm going to graph the second piece, which has an intercept of -4 and a slope of 1/2. So up 1/2, and again I want to work my way backwards so that this thing at least hits where we have the separation happening. They are not both always true. Our inequality says that one of them is true before -3 and one of them is true after -3. So we need to look at those inequalities. The top one that I graphed in blue says that it is true when x is bigger than -3, which means to the right of -3. So I want the blue to exist on the right, means that it should not exist on the left. So I'm going to erase that side out. The second one that I did in purple says that it is true when x is less than -3, which means to the left. So I want it to exist on the left. That means I need to erase where it exists on the right. And the last thing I need to do is decide, since they didn't fit together perfectly, one of them should have a closed endpoint and one of them should have an open endpoint on that red line. The one that I graphed in blue, the first one, has an equal to bar. Equal to bar means closed endpoint. So I'm going to get a closed endpoint on that. And the other one, if I look at the inequality, does not have an equal to bar. So that one gets an open endpoint. So the graph is going along, behaving as 1/2 x minus 4, and then all of a sudden, at where x is -3, it changes and starts to behave like a different line.
Can you go over the beginning again with the inequalities?
Yep, so the inequalities, that figures out where we're going to put that separation line in. So since it's at x is -3, at the vertical line where x is -3, I draw in that red line, and that tells me where the change is going to happen.
So the numbers will always be the same with the...
Right. Okay. All right, so then today we are going to look at some more of these. I think this is example 5 on your sheet, yes? Okay. This is going to be a special kind of piecewise function for us. So if we look at the parts of it, we have inequalities again. These inequalities have a little bit more going on, and because they're between inequalities, it's not just a one-sided, a greater than or less than, but x is between two values. And if we look at what's in front of there, it's just a number. Okay? So if we're thinking of these like equations, our equations are like y equals 1, y equals 2, y equals 3, and y equals 4. Because there's no x's in there. There's no x before the semicolon, so there's no x in the equation part. There's x's in the inequalities, but not in the equation part. So if I were to graph the line of like y equals 1, y equals 2, y equals 3, y equals 4, what kind of lines are those?
Horizontal.
Horizontal. So a y equals line needs to cross our y-axis, so those would be horizontal lines at whatever height it says there. So this is called a step function, because when we graph it out, what we're going to have is these little tiny segments at different given heights. So the first one here says that it has a height of 1 when x is between 0 and 1. So what I want to do is on my x-axis, figure out where 0 and 1 are, and between 0 and 1 go up to a height of 1. And I just get a little line segment there. The line segment needs some endpoints. I can make it show up a little bit darker. I don't know if that'll make it better or worse. The line segment needs some endpoints. So if I look at the inequality on the 0 side, there's an equal to bar. So I'm going to put a big closed dot on that side. And on the other side, I'm going to put an open dot because there was no equal bar.
Yes. Okay.
The second one says that it should have a height of 2 and exist between where x is 1 and x is 2. So I find x is 1 and x is 2. I go up to a height of 2 and put a little line segment. Again, on the 1 side, I get my closed circle, and on the 2 side, I get my open circle. The third one says I'm going to have a height of 3 that exists between where x is 2 and x is 3. So where x is 2 and x is 3. Go up to a height of 3. Closed circle on the 2 side, open circle on the 3 side. And then the last one says height is 4 between where x is 3 and x is 4. So I find x is 3 and x is 4 on my x-axis. Go up to a height of 4 on my y-axis. And closed circle and open circle. So these are called step functions because that's what they look like. They look like just little stair steps. They don't have to always be perfectly spaced like these. These all have the same length of 1 and they're only stepping up by 1 each time. That does not have to be the case. You could have a step function that when you graph it out has like a long step down here, and then the next step is really short, and the next step might be longer again but closer together vertically. So they can take kind of big jumps, and some steps can have a longer length than other ones. So they don't have to be perfectly the same type of step each time. Okay? We can take big jumps between on y values, and the x values can be long or short. But they're all called step functions when it's just all these little horizontal segments. Questions? Okay, let's look at another one. So again, in front of those semicolons, we just have numbers. That means this is going to create a step function where the front number defines our height and the inequality defines where we want that height to exist. So I want to be at a height of 1 between -4 and -3. So on my x-axis, I want to go to -4 and -3. And then on my y-axis, I would want to go to where I have a height of 1 and put a little line segment. The equal to bar is on the -4 side, so it gets the closed circle, and the -3 gets the open circle. Then I have a 2 between -3 and -2, so I want to find -3 and -2 on my x-axis and go up to a height of 2. Closed circle on the -3, open on the -2. Then I have a 3 between -2 and -1, so I find -2 and -1 on my x-axis and go up to a height of 3 on my y-axis closed on the -2, open on the -1. And the last piece says height of 4 between -1 and 0. So my -1 and 0 on my x-axis, height of 4 on the y-axis, closed on the -1, open on the 0. Okay, so again, these ones are nice and symmetrical steps, but they don't have to be. So some of them can be longer, some of them can be shorter, some of them can take bigger jumps, some of them can be closer together.
Do you have to write like the numbers below, like -4, -2?
No, you don't have to label your axes at all. I just do that to help people see why I'm drawing them, where I'm drawing them. But you don't have to label your axes unless you start counting by something other than ones. Questions on how to draw a step function? Okay, so the final part of the lesson then is on how to come up with an equation. So in these first parts, I gave the equation and you created the graph. So here I'm going to give you the graph and you have to figure out the equation that would go with this. So we're going to have f of x equals, and we need a couple pieces. First thing I want to do is split for the inequality. So where is this piece, this function breaking apart?
0.
At 0. So I'm going to have something happening for x is smaller than 0 and something for x is bigger than 0. One of those should have an equal to bar. How can I tell which one? The one with the closed circle. So what I want to do is look at the function and find my closed circle at that breaking point. Does that go with the less than or the greater than? The greater than, because that's the one that's pointing to the right. That's on the right-hand piece of the function, so that's the one for x is greater than 0. Now I have to figure out what actually are these two functions. So then we think about y equals mx plus b. So for the first function, we'll do the left-hand one first. If I think about y equals mx plus b, what is the b value?
2.
2. That's our intercept, so I'm going to have plus 2. And what is our m value?
1.
1. M is slope, and that's up 1 over 1. So I'm going to have 1x plus 2 for that piece, or just x plus 2. Then for the second piece, again thinking about y equals mx plus b, what is b?
0.
0. That's our intercept, and it's going through 0, 0. And what is m?
X. Or just
1, or just x, because our slope is 1 over 1. So we could say 1x plus 0, or that whole thing could just be x. Questions? So earlier in this chapter, we learned how to come up with the equation given a graph, thinking about where the intercept is and what the slope is from the picture. So we're doing that twice, at least in the problem, sometimes maybe even more than twice. But then we have that inequality portion as well, where we have to say it's happening on the left of some breaking value and on the right of some breaking value. Okay, so we're going to start with naming our function. F of x is 2 pieces again. I like to think about where we're breaking apart first. So where's this one breaking apart? -1. So I'm going to have something to the left of -1 and something to the right of -1. One of those should get an equal to bar. So to determine that, I look for the closed endpoint, which is this upper one. And so is that the less than or the greater than piece? That's the less than piece because that's on the piece that's on the left side. Then we need to determine what are these 2 pieces. So I'm going to look at that left-handed one first. If I want to think of this as y equals mx plus b, I can't actually see the b value. So what we need to do is first determine the slope of that line. What is the slope?
1.
1, up 1 over 1. And continue that out until you get yourself to your b value. Okay? So you need to know what the b value is to be able to write the equation. So if you can't actually see it, you just have to continue the piece out until you get there. So what would the b value be on that one? 2. And we said we had a slope of 1. For the second piece, what is the b value? Negative a half. And what's the slope?
1 over 2.
I go 1 and 2, but what kind of a 1 is that?
Negative.
It's a fall 1. So we have a slope of negative a half x, and then minus a half for the intercept. Remember, rising lines and falling lines. Falling lines should have a negative slope. Okay. Questions?
How do you get like the second number? 'Cause you-
The second number in the equation part,
Yeah.
that's the intercept value. That's the b, so that's where it hits the y-axis.
Oh, okay.
I want to try one more of these that has more pieces to it. I'll just make it up. Okay. So this is our function. How many pieces does it have?
3.
3 pieces. Okay, so it has the falling piece, the flat piece, and then a rising piece. So this one, we're going to need room to write 3 functions in here. What is the first breaking point? What is the first place that 2 pieces are meeting up?
-2.
At -2 there in our x value. So I've got something that is happening to the left of -2. Then that middle piece, what's its other breaking point on the other side?
2.
At +2. So that middle piece is existing between -2 and 2. And that last piece is existing when x is bigger than +2. Okay, so I have a left piece to the left of -2. I have a middle piece between -2 and 2. And I have a right piece over to the right of +2. These 3 pieces came together perfectly, so it doesn't really matter where we put our equal to bars, but we do have to put them somewhere. When that happens, I usually just stick them both on the middle piece. You can't put it technically on all of the pieces because that would open up the opportunity for it to not be a function if they didn't fit together perfectly. It's not something I'm going to be really picky about because when they do come together, it doesn't really matter where the equal to bars go. So now we have to come up with our equations for our 3 lines. So the first line, I'm going to start over on the left. This line, we cannot see its intercept. So if we're thinking about y equals mx plus b, we don't know what its intercept is, but what is its m? What is its slope?
-2 over 1.
-2 over 1, down 2 over 1. So our slope is -2. And then we have to find our b value. And so what we're going to do is continue that slope out, down 2 over 1, down 2 over 1, till we see where would it hit. And so where is that?
-6.
-6. Okay, so if you cannot see your intercept, find your slope, continue out the line until it would hit to determine what the intercept would be. The middle piece. The middle piece is horizontal, which is kind of like our step functions. In our step functions, the equation is just the number of the height of that segment. So what is the height of that segment? -2. So that's all we need there is -2. It has 0 slope. There's a horizontal piece, so we just need its height, which is -2. Then we need our third piece. We can't see its intercept, but what is its slope? 1x is going up 1 and over 1. So what we want to do is continue that out backwards until we see what its intercept would be, and that would be what? -4. And so then that's our piecewise function. Has our 3 separate equations, and then it has the inequalities that say where each of those equations exist. Questions? Okay, so this is your homework from section 2.7 in your book, and if you are doing honors, a couple extra. Honors, you are also going to do 54 and 55, which is a pair, they go together, and 58 and 59.